All right, hello folks. This is Mike coming back at you with a continuation of our previous video on ratios, proportions, and percents. In the previous video, we talked about ratios and proportions and solving proportions using cross multiplication, as well as talking about unit pricing. In this video, we're going to do a quick review of percents, and then we're going to see some other real-life applications of linear equations involving those guys. So we all know percents. We've all seen percents before. We see them in stores when we go shopping, all that fun stuff. But percents, can be looked at as ratios. Percents are really just ratios where the denominator is always 100. So if you see, say, 50% off, then as a ratio, you can say that's 50 over 100, and I think we all know that 50 over 100 is the same thing as 1/2, so it's half off, or ratio of 1/2. So just a quick, very quick review of converting between decimals and percents. If you have a decimal and you want to convert it to a percentage, take the decimal point, move it 2 places to the right from where it is, and then you're going to add the percent sign. If you wanted to take a percent and convert it into a decimal, you're going to take your percent that you have, you're going to drop that percent sign, then you're going to take the decimal point and you're going to move it 2 places to the left, and then that's the decimal that you are going to wind up with. Now, a formula which gives us extra money inside of our savings accounts every year, which is double thumbs up for us. We all like more money. So a handy and simple formula for finding simple interest. I specify simple interest because there is such a thing as compound interest on some amount of money or some amount of dollars, which I'll call P here, that are deposited into your account. And your account has an annual interest rate, which will be represented by R. And the key thing to keep in mind here is that R is always used as a decimal, not as a percentage. And if we want to find the amount of interest being given to us for the money sitting in there for T years, T is some frame of time, then the interest that you get, I, is equal to P times R times T. How much money you put in times the annual interest rate used as a decimal times how long it's been in there in years. So here's a sample problem. If you deposit $4,000 into a savings account that has an annual interest rate of 5% and it sits there for 3 years, how much simple interest will you have? What about if you only let the money sit in there for 7 months? So P is the amount of money that we have sitting inside of the savings account. It's how much money we put in. And we deposited $4,000. So that's my P value there. R, we said, was the annual interest rate. That's used as a decimal. So 5% as a decimal, hopefully you see that that's going to be 0.05. And then the time, how long does the money sit in there in terms of years? Well, we're saying it sits in there for 3 years. So 3 is going to be my T value. So the simple interest I'm going to have in this case, my P value of 4,000 times my R value, again used as a decimal, times my T value, times 3 in this case. So all we have to do is we just have to multiply these numbers. And when you multiply these numbers out, you can plug this into your calculator, or you can do this in your head if you're that comfortable with doing the calculations. You're going to get 600. and obviously this is money, so we're talking dollars here. So this is $600 that you're going to get in simple interest over these 3 years. We have a second piece to this problem. It says, how about after only 7 months? So same amount of money being put in, same interest rate, but now the time that's been sitting in there is only 7 months. Okay, well, it's still the same formula, P times R times T. The amount of money we put in is the same. The interest rate is the same, still using that as 0.05. But now, the time is not the same. And a common error that would be made is that people would just put 7. But they are not keeping in mind that we said 7 months. And time is measured here in years. So what ratio or what part of a year is 7 months? Well, there's 7 months that's been sitting in there out of 12 months in the full year. So the time, in terms of years, is going to be 7 over 12. 7 out of the 12 months. So now we just have to multiply these numbers out. And if you multiply those numbers out, you are going to come up with 1,400 divided by 12. But we want to get this in terms of an actual number in terms of dollars and cents. So if you do 1,400 divided by 12, you get approximately, and recall that this is the symbol that we use to stand for close to. It's not exactly equal, but close to. We get $116.67. We rounded to 2 decimal places because we're talking money and we only talk about pennies here. So we always go to 2 decimal places. So there's a sample problem that has to do with finding simple interest here. This one was a little bit odd compared to the other ones because we had 3 different letters here and we had 3 different things to plug in, but it's a very straightforward, very basic formula to use. We're not doing anything really complicated here. Next sample involving percentages. This one will be a bit more familiar with what we had seen from previous videos. A scientist mixes 40 liters of a 30% acid solution with some quantity of 50% acid solution to make a mixture that is 35% acid. How many liters of 50% acid solution have to be added? Okay, so this is perhaps, just on the sound of it, a little bit more tricky. This may seem like we can't solve it, but we actually can. And we'll reason this out as we go through the problem. And how we're going to set this problem up and how we're going to set up the equation that we have to solve is we're going to look at this as what things do we have now and what do we want to have. What pieces do we have now and what do we have to do to them to get what we want. So what we have now is we have 40 liters of a 30% acid solution. So if I do 30% as a decimal, that is 0.3, and that's being multiplied by 40. And what that tells us is how much acid there is in this first solution here. Now, the other acid solution that I'm told that I have, I know that it's 50% acid, but I don't know how much of it I have here. So I'm going to say it's going to be 0.5. Obviously 50% as a decimal. And then the quantity that I have is unknown. That's actually the thing that I want to solve for. So since this is what's unknown and I need to figure out what this thing is, what this quantity is, I'm going to call that quantity x. So these are the two things that I have. And the problem says when I combine these things, it's going to be a mixture that is 35% acid. So this is how much acid is in the first solution. This is how much acid is in the second one. And it says that when I combine these, or when I add these, I'm going to get a mixture that is 35% acid. 35% as a decimal is 0.35. But now what's the total number of liters that I have here? Well, it's the 40 plus whatever this number of liters was, whatever that quantity was. So it's going to be the sum of this unknown quantity and 40. So 0.35 times the quantity, x plus 40. Okay, so now I'm actually going to let you figure this one out on your own. We've set up the linear equation that is in one variable. I'll let you figure this problem out from here, and we will go through this problem in class. And we'll see if you got the correct answer. Guys, if you have any questions or comments, please be sure to reach out to me. Send me emails, send me a text, stop into my office, give me a call on the phone, whatever you have to do. Otherwise, until the next video, take it easy, guys.